Good morning, students. So we will continue our discussion of WLAN. How in yesterday class, in the last class we studied about what are the architecture of WLAN and what is the medium access control it uses. And today we will carry forward our discussion to how roaming is managed. We talked about synchronization in the last class as well. So we will talk about roaming, and then we will talk about Bluetooth connection. In today's class, okay? So first of all, what do you mean by roaming? Roaming can be defined as, changing the subscriber, changing its, location from one place to another. That means to a different access point. Suppose this network is managed by access point 1 and this network is managed by access point 2. Roaming means changing from this access point to that access point without losing connection. The key point is without losing connection. That means we can change access point, but user will not feel any disruption of service. Okay, the service we will continue to get even though we change our home location and we move to some other point. So user need not user need not be stationary. User need not be stationary. It can travel from one location to another, and the service of this access point will be maintained. Without losing connection, it will continue to get its service. That phenomenon is called roaming. Okay. So the example is that suppose you have a Odisha Vodafone connection. Suppose now you want to change and you want to go for a few days to some other state like we may say Karnataka or Tamil Nadu, for example. Now, will you lose your service of Odisha Vodafone? You won't, because you will be on roaming and you will be on a different location and you will continue to get your service from that access point, from the access point that is located in Tamil Nadu. Okay, so this is called roaming. That means we can change location, but we can continue to get service without losing connection. Okay, that is what is meant by roaming. Okay, so what happens in roaming internally is that the access point change will occur and these access point will communicate with the visiting location. This is called visiting location, V location. This is called home location, H location. When we move from home location to V location, then this AP1 will communicate with the AP of the visiting location and will tell that, see, this is on roaming. You continue to give service to this subscriber who belong to my location. Then this AP2 will continue to give service and the user doesn't feel any discomfort or will not face any problem in terms of its service. Okay, so that's why we say mobile computing is extremely reliable. Okay, you need not confine to a specific location to access the service or enjoy the service. Okay, even though you change location, you will continue to get the service. This is called roaming. And the phenomenon when we change borders, okay, when you change borders, usually when you change from one state to another state, you may be getting a message that welcome to Vodafone Odisha or welcome to Vodafone Chhattisgarh. You may get such kind of messages. Why? Because that time there is an exchange of messages between the two AP and you will get to know that yes, now I am getting my service from AP2, that is the visitor location AP. So that change, the instance when you change from one border to another border, that is called handoff. The instance when you change from one location to another location, that is one AP to another AP, and you get to know that yes, I have changed location. Now the service is, my service provider is someone else. That, that stage or that phenomenon is called handoff. HANDOFF. Okay. So this was about roaming. Now, what is a Bluetooth connection, you may ask? Okay. So, Bluetooth connection is a type of ad hoc network. I told you what is the ad hoc network. Do you remember? Here we do not have any access point or anything. There is dedicated, connection between point to point. This is called an ad hoc network, which is not connected to internet. Not connected to internet. Not connected to internet, that is, it is not connected to the world of networks. It is just a connection among itself. It is also a type of peer-to-peer connection. Peer-to-peer connection. So Bluetooth is also an ad hoc connection in which there is connection between, point-to-point connection, that is one device to just another device, or it may be point to multi-point. But it is an ad hoc network. It is not connected to outside world. The data is strictly restricted to the participant nodes. Okay, the data is what data of only participating node. Participating node. Now, such a connection which has a small range and few participants who are connected among themselves is called a piconet. So, the network connection of Bluetooth is called a piconet. Piconet. So, this is important term to remember. So, the network for a Bluetooth is what we call a piconet. Okay. So, in piconet, we can have point-to-point connection. In piconet, we can have point-to-point connection, or we can have multi-point connection. I'll just say we can have multi-point connection. So in piconet, we can either have point-to-point connection, multi-point connection. Point-to-point connection is between one device to another device. It may be a sender, it may be a receiver, or vice versa. Whoever is the sender, the initiator of communication is what we call master. Okay, whoever that initiates the connection is called master, and the one which just join or to participate in the connection to receive things is called a slave. Okay, so in a piconet there can be maximum 7 members. Maximum 7 members. Okay, only one master possible. So in piconet, generally we can have maximum 7 nodes to participate. Among them, one can be master only, and rest can be receiver. So when there is one-to-one connection, we call it point-to-point. When there is one master and several slaves or several receiver, we say it a point to multi-point. So this is a point-to-point connection, and this is a multi-point connection, as you can see. Now, if now Bluetooth connection can also be extended. You may say that, ma'am, I am, currently I am sending data to my friend, and at the same time, that there may be other connection in the periphery as well, that someone might be slave. Taking this example, this becomes a piconet 2 then. So here this device, this is an overlapping device. That means it is a part of two connections. I may be connected to two connections. Okay, I may be connected to this master, and at the same time, I may be able to send data to some other. I can be a master to some other connection, and I can be a slave to some other connection. In that case, we say this is a case of multiple piconets connected. Okay, when there is a connection of multiple piconets, we call it a scatter net. Scatter net. So, connection of multiple piconets by overlapping devices is called scatter net. What is an overlapping device? A device which participates by some role in multiple connection. How they can be in some role? Suppose in connection 1 they are acting as masters, but in connection 2 they may be acting as a slave. So they are connected with both the connections simultaneously, both piconets simultaneously. So such an entire net is called scatter net. Okay. So suppose, so I think you got the idea. Now since in a piconet we can have maximum 7 number, each system is addressed by 3 bits. Each station is addressed as 3 bit. Why 3 bit? You know, in binary system, to represent 2 to the power n entities, we need n bits. Why? To represent 4 people, suppose, or 4 entities, it may be anything. You may address it using 2 bits. Isn't it 00011011? Similarly, if we have 7 members, can we represent it using 2 bits? No, right? We can. In 2 bits we can maximum represent 2 to the power n, that is with 2 bits we can represent 2 to the power 2, that is 4. We can maximally allocate 4 addresses. But for 7 members, since it is exceeding 4, we must need 3 bits from 000 to 111. To represent this, we must have 3 bits. Okay, so that's why since the number of members are 7, to address each station or each node, we require 3 bits. The address may start from 000 until 111. Okay, and one among these devices will be a master and rest will be slave inside a piconet. So this was all about Bluetooth connection. The network for a Bluetooth connection is referred to as a piconet. We studied all the characteristics of piconet, and several piconets connected is called a scatter net. Okay. So next, in the next class, we will move to a new chapter called ubiquitous connections. Okay. Ubiquitous network. What do you mean by ubiquitous first of all? Ubiquitous means present everywhere. Okay. I will just give you a brief idea. What do you mean by ubiquitous? Ubiquitous means present everywhere. So mobile computing is called a sort of ubiquitous. Why? Because mobile connection service is available almost everywhere. So if you have a mobile and you have an internet connection, you are always connected to internet. You may exchange data, you may search something, you can connect to someone. So that means your privacy is just gone simply. Okay, because anyone can trace you, anyone can track you. So this kind of service, mobile computing, is kind of ubiquitous because it is present everywhere. Okay, so in ubiquitous mobile communication system or ubiquitous service, we will understand how the evolution of the progress of mobile computing took place from 1G to 2G to 2.5G to 3G to now we are in the era of almost everyone is using 4G, but 5G has also come. Okay, in several places we are using 5G. Okay, so how this evolution took place and kind of how it is present everywhere now is we will get the idea in the next class. Okay. So meanwhile, if you have any doubt, you can post it in the comment section and we will continue in the next class. Thank you.